210, which is naming, but let's really quickly review on 2.9, or that last section about determining or classifying matter as either ionic or covalent. Do you remember the basic rule right now? If a compound is ionic if what? Don't think in terms of its property, think in terms of its periodic table property, its location on the periodic table, okay? A compound is ionic. A structure that's made up of more than one atom of more than one element, okay? That's a compound. It is an ionic compound if what condition is met? Yeah. Okay, that's a chemical or a physical property, conducts electricity. But in terms of the periodic table, it's ionic if it has a metal in it. Right. So it's ionic if it has a metal in it, and because it has a metal in it, it will conduct electricity. It's not ionic because it conducts electricity. It conducts electricity because it has a metal in it. Okay? More specifically, it conducts electricity because it's ionic, and ionics have metals in them. It's probably the best way to think about it. So a compound, if we have a chemical formula for a compound, we're going to ask, is it ionic or is it covalent? It's ionic if it has at least one metal in it. Here's the deal. It'll have one metal in it. Where will that metal be in the chemical name? Right in the front. We put the metals first. So remember we did that example yesterday where the very first element, lithium, I forget the full molecule, but the very first element was a metal. Once you find one metal, you're done. If it has a metal, it will have one metal, and you find it first if the formula is written appropriately. And it's covalent if it has only non-metals in it. Here's the deal. You're not going to have a compound that has only metals. Again, why that is will make more sense later. If a compound, when you have a compound, it will have a metal and a nonmetal, or it'll have more than one nonmetal. So if it has a metal, which if the name of the compound is written appropriately, should be the very first element listed, if it has that metal there, then it is ionic. And if it does not have a metal in it, it is covalent. And because it's ionic, it conducts electricity. And because it's covalent, it does not conduct electricity. So that point right there, to figure out whether or not a compound is ionic or covalent, is essential in being able to appropriately name the molecules, giving names to these compounds that are built up from more than one element. We've got two different rules. One, we're going to have one set of rules for naming ionic compounds and another set of rules for naming the covalent compounds. And they're similar, but they're not exactly the same. Ultimately, this is what you're going to find out. This is what makes naming ionics different from naming covalents. In an ionic compound, it's a mixture of a metal and a nonmetal. That metal and that nonmetal can only come together in one specific way. There's only one combination that works. And because there's only one combination that works, the naming system for the ionics is very simple compared to the covalents. Because when we get to the covalent naming system, there is more than one way that two elements can combine. And so you have to be a lot more specific. The covalent naming paradigm is much more specific than the ionic naming paradigm. Okay? So we're going to start with the easier one. In this case, the ionic compounds. And when we name the ionic compound, let's say we have the formula written out in front of us, what we're going to do is look at that very first element there, and we're going to start naming it. We're going to say the name by reading from left to right, just like we do in everything else. And the first element is going to keep its elemental name. The second element is going to take on its "ide" name. That's why you had to learn that table. That's why fluorine versus fluoride. Because if I have a formula, and in that case my last element was fluorine, I'm going to pronounce it fluoride, not fluorine. And we'll give a couple examples of this. So that's why memorizing table 2.1 is so important. When you name it, you're going to lead from left to right. You're going to use the first element's elemental name, and you're going to give the second element its "ide" name. Because the second element, or last element, in case we get longer streams, right, longer molecules, but for right now they're going to be simple, probably two-element compounds. Elemental name for the first, ide name for the second. Read it from left to right. Read in order from left to right. So we're going to do it. So the easiest way to see it is to give an example. We've already done the table. You've done your test. This is where we would make sure that you understood it. Hopefully you do. So let's look at this NaCl formula. Now we all know what it is, but don't think right now, hey, I know how to say that. Well, how do you know how to say it? Let's use something that's more obvious and learn process. Okay. So first question. In this formula we have up here, NaCl. Again, pretend you don't know what it is. Is it ionic or covalent, and why? I'm going to say that it's an ionic compound. Why? Correct. Sodium is over on column 1. It's a column 1A element, sodium. Because it's to the left of the jagged line, it's a metal. Therefore, there's a metal in this compound. Therefore, it is ionic. I didn't have to look at chlorine. Once I got a metal hit on sodium, I'm done. Right? So, it's ionic because it contains sodium, and sodium is a metal. Then, I'm going to say the name with sodium, keeping its name sodium, but the paradigm says first element keeps its name, second element gets what? Its ide name. So chlorine becomes chloride. See? So if we didn't have a naming paradigm, what would we call it? We'd probably call it, well, it's sodium chlorine. Well, that would tell me I've got a sodium and a chlorine atom. Fine. But the second part, or the second element, gets its ide name, and so we read it. Sodium stays sodium, chlorine becomes chloride, it's sodium chloride. Right? Second example, K2O. Ionic or covalent?
Ionic.
Ionic because?
Metal.
What is that metal?
It's potassium.
Potassium. Okay, so it's an ionic compound. K is potassium. O is oxygen. But since it's ionic, the potassium, the metal which leads, keeps its name. It doesn't have to change its name. So it's potassium stays potassium. But oxygen has to become oxide. And so the name of the molecule that has 2 potassium atoms and 1 oxygen atom is potassium oxide. Okay. Screaming through my notes. I can't even keep up with them over here. I'm so fast. So it gives me either I've got too many notes or I'm going way too fast. So am I going way too fast? Okay. So you're either, some of you look really bored or really confused, and sometimes the difference for me is hard to tell. Okay? Except when you're doing this. I take that as bored, not as sleepy. We haven't pulled out the goggles in here yet, have we?
No.
Oh, you heard about that?
No.
Okay. We pull out the when people start getting drowsy in class, and you're always allowed to stand up and go to the back, take notes standing up, or some other to the side of the class. That's always fine. Do that. But if you start nodding off in class, then I go and pass out goggles to everybody sitting around you, and you'll have to wear them, and so I can throw erasers at you when you fall asleep. But I don't want to hit the people around you by accident and damage their eyes, so everybody around you has to wear glasses.
That's funny.
So, maybe you want to take that on and everybody gets to wear those little plastic lab glasses, but most people don't like them. And they make those circles around your eyes and stuff, and it's just not pretty. So don't be the one that makes your classmates not look pretty. So potassium oxide. Again, it's simple because I'm going to say right now that potassium and oxygen only combine as K2O. They don't make K2O2. They don't make K3O. Potassium and oxygen, when you bring them together, they only form K2O. So I don't need a lot of the information. If I tell you it's potassium oxide, it's a very quick way to say it's got potassium in it, it's got oxygen in it, And after a while you'll go, oh, I know what that formula is. Why? Because it's potassium and oxygen. And this is the only way they can combine. Again, how they combine is part of the discovery we'll do in a later module. But it's the only way they can combine. Therefore, if it has potassium and it has oxygen, and those are the only two elements, and they combine, it's going to be potassium oxide. That's the name every time because it can only form that one compound. Covalent compounds now. We're on the other side. That was it for naming ionic compounds. Any questions on how to name an ionic compound? First of all, any problems with identifying whether or not a compound is ionic or covalent? Because if you can do that, then you can move on to the next step, which is using that paradigm for naming it. So if it has a metal in it, it's going to be ionic. If it's ionic, you're going to name the metals left to right, or excuse me, you're going to name the elements left to right. Metal leads, last element gets its ide name, and read it from left to right. Second paradigm is this one for the covalent compounds. Remember, covalent compounds can have multiple combinations of the same two elements. So for me to say, well, like one of the examples is carbon dioxide or carbon monoxide. I just can't say carbon oxide because if I have carbon and oxygen, I can make more than one kind of compound out of that. So you need more information. And how do we get that more information? Well, we start with the name of each element in the formula in order. We're going to read it from left to right using each element's name. We're going to add some additional information. We're going to take the prefixes and add it before the name. It'll make sense when we do the example. But if I looked across there and I saw an element, let's say that it was nitrogen and had a 5 subscript, that would tell you when I read the chemical name N sub 5 that I have 5 nitrogens in that. But when we say the name, we don't say N5. We would have to put the penta in front of it. That's why we're going to memorize table 2 for tomorrow's quiz. You've got to look at the subscript and say, how do I say that subscript as a prefix? And again, it'll make more sense when we do an example. And then still replace the last element's name with its ide name. So the last element in the correctly written formula is always going to have an ide name. But you're going to know whether it's covalent or ionic if it's named appropriately because you're going to use words like mono, di, tri, tetra, penta. You're going to use those in the name. With one exception. There's always an exception, right? Some of you are exceptional and some of you are the exception. Here we go. We're still going to read them left to right, but here's the exception. Just like we have the subscript 1, which we don't use. The 1 is always implied. 1 in the prefix is said as mono. Mono means 1. But we never start a compound's name with the word mono. We don't start with mono. So when we name it out, if we look at the first element in the name, and if it has an implied subscript of 1, we don't say mono. The names never start with mono. Now, if the second element, the third element, the fourth element, if it's just a 1, we do say the mono. We just drop the mono for the first element. Here we go. So there is the table. That's why you need to say, well, I see a subscript of a 4, I'm going to say tetra. I see a subscript of a 9, I'm going to say nona. You've got to be able to translate between the prefixes and the meaning, because the meaning will be written as a subscript when you write it as a chemical formula. When you say it, you need to put the subscript to convert it to a prefix. Here's what that looks like. CO2. It's a covalent compound, covalent molecule. Why? Carbon and oxygen are both nonmetals. It's covalent. And like I just said, there are more than one ways to combine carbon and oxygen. So a CO and a CO2, they're different. They have to have different names because every compound has its own unique name. So in naming this molecule, CO2, I assert, first of all, it's a covalent compound. So I'm going to look at each element in order from left to right, and I'm going to add the prefixes. So the first element, carbon. How many do I have? Well, hopefully you see now that the carbon has an implied subscript of 1. If it didn't have an implied 1, it wouldn't show up. It wouldn't be in the formula. It has to have at least a 1 implied to be there, and if it has 2 or greater, it has to be written there. So this is 1 carbon atom and 2 oxygen atoms combining to make this molecule. So when I look at the carbon, I said, I've only got 1 carbon, and that would be monocarbon. Mono being the way we say 1. And then the second element, oxygen, there are 2 of them. See, there are 2 because the formula has a subscript of 2. That tells me I've got 2 of whatever it's subscripting, 2 oxygens. But when I say that, I say it as a di, because 2 becomes di. So as right now in this process, we would say, well, that element is monocarbon dioxygen. Now, we have to go back and drop any leading mono. Monocarbon dioxygen, we don't lead with a mono, so we drop it. So monocarbon just simply becomes carbon. And we have to ide the last element's name. In this case, it's oxygen, so dioxygen becomes dioxide. And we read it from left to right, carbon dioxide. So when I see carbon dioxide in my mind, if I wrote the formula, carbon, implied subscript 1, di means whatever I'm about to say has a subscript 2, oxide, that's the ide name for oxygen, O, CO2. So you go both ways. Go from a chemical name to the written name, and from the written name back to the chemical formula. Formula to name, name to formula, using that process. So an example, it's in your book on example 2.4, is this molecule here, Al2O3. What's the first question you're going to ask as you start to determine what the name is? Go ahead. Is it ionic or covalent? Ask that every time. Is this ionic or covalent? It's ionic because aluminum is a metal. Good. Aluminum is a metal, so it's ionic. So what naming paradigm am I going to use? Am I going to use monos, dis, tris, or not? No. Because it's ionic, it's a metal, so it's ionic, which means I start with the name of the first element, then I ide the second element, and then I read it from left to right. So what's the first element's name? Aluminum. It's ionic, so I don't worry about the subscripts. And the last element is oxygen, so it becomes oxide. Good. So aluminum, oxygen, aluminum stays aluminum, leads, oxygen becomes oxide, and the compound is aluminum oxide. First question you're going to ask, what is it? Ionic or covalent? Which is it? Because? They're covalent because they're all nonmetals. Good. So on this one, am I going to use mono, di, tris or not? Yes, I am. So I'm going to add the prefixes, then I'm going to drop any leading monos, then I'm going to replace the last element with its ide name, and then I'm going to read it from left to right. So looking at its name, we've already said this is covalent, so I have to look at the suffix, or look at the subscripts and use those as prefixes when I say it. So I start from left to right, and what is the subscript on the P? Okay, let me go over here to this one. It's phosphorus and hydrogen, and there is 1 phosphorus, so I can start by thinking it's monophosphorus. It's okay to think that way initially, but we're going to drop it because we can't lead with mono, right? But 1 phosphorus would be monophosphorus, and 3 hydrogens would be trihydrogen. Okay, so again, when I'm saying the name, I look for a subscript first because that'll be my prefix. The 1 makes it monophosphorus, the 3 makes it trihydrogen. So right now, monophosphorus trihydrogen. However, monophosphorus becomes phosphorus because we drop a leading mono, and what else happens next? So hydrogen becomes hydride, and so trihydrogen becomes trihydride, and then we say it from left to right, phosphorus trihydride. You see, you're becoming chemists already. You're getting this. Okay? Man, I'm going to run out of slides here. We've only got 5 minutes left. On your own, name the following compounds. Let's talk it through. The first one, ionic or covalent? Covalent because there are no metals in it. So I have to use the covalent naming paradigm, which uses the prefixes. I would look at the first one and say, well, that would be a monocarbon, but I don't use the monos, so it's carbon. 4 is a tetra, fluorine, but it becomes a fluoride, so it's carbon tetrafluoride. The second one, aluminum 2s3, or Al2s3. Hopefully now you're seeing, wait a minute, aluminum, I know something about aluminum. It is a metal, therefore this is ionic, therefore it's pretty straightforward. All it is aluminum, sulfur becomes sulfide, and it's aluminum sulfide. Because it's ionic, I don't need to worry about the subscripts becoming prefixes. In the third case, what are the two elements? Phosphorus and oxygen. They are both nonmetals, therefore this is covalent, therefore I need to use the subscripts as prefixes, therefore it becomes diphosphorus trioxygen becomes oxide. Diphosphorus trioxide. Calcium and oxygen. Ionic or covalent? That's the first thing you're always going to ask when you name it. Ionic or covalent? Ionic. Therefore, it's just going to be the names with an "ide." Calcium oxide. In your paper, go ahead and write down, what is the chemical formula for sulfur hexafluoride? The fact that it has a prefix in here, do you see hexa, the prefix? You know right there, if it's named correctly, that this is a covalent molecule. Why? Because ionics don't use the prefixes. This has to be a covalent molecule. So you know just from the name that sulfur and that element there, which I don't want to give you, but anyway, it'll come out of your answer, but that these are both nonmetals, and they can combine in multiple ways, and this is just one of them. So I need to identify the specific way they've combined. So sulfur hexafluoride. S, of course, is the symbol for sulfur. Hexa is a prefix for 6. And fluoride is the ide name for the chemical fluorine. The symbol is F. And so I have 1 sulfur, 6 fluoride. How would I write that out? Becomes SF6. If I'm reading this, I say, well, look at that. They're both nonmetals. This is covalent. It's a monosulfur hexafluorine that becomes sulfur hexafluoride. Because I dropped the mono and I have to ide the last chemical name. What about pentacarbon decahydride? Last one, I think. Life is hard, isn't it? Pentacarbon decahydride. So my first symbol is going to be, well, reading it from left to right. Penta stands for 5. Carbon, the symbol is C. Deca stands for 10. And hydride is the ide name of hydrogen, whose symbol is H. So reading across from left to right, I should see 5C10H, but we write the prefixes as subscripts, which is why it comes across as C5H10. Pentacarbon decahydride.